How you all are doing? Hope good. Fine. So today we will discuss the question, the source which I have explained into my sessions. Okay. So I will just start with the question of a cyclic quadrilateral where a cyclic quadrilateral is given and we need to find the value, the different values of these angles. Okay. So let us say if a cyclic quadrilateral is given to us, right? So I am drawing it. So I'm just taking this cap. This will help us to make a good circle, right? This is a circle. Now, what we need to do in this question, a cyclic quadrilateral is given like this. Let's say it may be not as per scale, but you can consider this, right? If this is A, B, C, and D, this is the cyclic quadrilateral, right? Then we need to find, and if this value is x, I mean to say this angle is x, this angle is 3x, and if this is the center of the circle, and let's say it's connected in this way, that from D to the center O, and from here it's connected to B like this, right? Now we need to find the value of this angle Y and angle DOB external. So I am just writing what are the angles we need to calculate. We need to calculate angle A, that is, you can say angle BAD. Angle BAD is what? It's X, right? It's X. And this angle BCD, is what? It's 3x, right? And this angle BOD, equal to what? All these angles we are going to calculate, right? And angle BOD external, I mean to say this one, right? Let's say angle BOD exterior, that is equal to, let's say Z, this one, right? So students, we need to find the value of angle BAD, this angle, and angles, whatever the angles you are seeing it over here, angle BAD, angle BCD, angle BOD, and BOD exterior, right? So students, see, observe this. This is a cyclic quadrilateral, right? This is a cyclic quadrilateral, and inside a cyclic quadrilateral, there is a relation, there is a theorem we are knowing that sum of the opposite angles of a cyclic quadrilateral is 180 degree, right? So here, angle BAD and angle BCD, I mean to say this angle and this angle, when they will add up, it will be equal to, the total sum will be equal to 180, right? So by the property of cyclic quadrilateral, we can say that angle BAD, right? Why? Because ABCD is a cyclic quadrilateral. Now, What is the value of angle BAD? It's x. Put up the value over here. What is the value of BCD? The BCD, what's that? It's 3x. 3x is equal to 180 degree, right? And when you add x and 3x, what you will get? You will get 4x as equal to 180 degree. Now, what is the value of x? It's 180 divided by, it's 180 by 4, which is equal to 45 degree, right? So the value of angle x is calculated as 45 degree. So this is our answer for angle BAD. So this is 45 degree. Now, what is the other angle? The other angle is BCD, which we need to calculate. It's 3 times x. Just see here. It's given. So, if this is angle BAD, then angle BCD is given as 3 times x. So, multiply the value of x as 45 degree with 3 to get the value of angle BCD. So, this will be equal to 135 degree. So angle BCD is calculated as 135 degree, right? So this is also calculated, the second part. What's the third part? Angle BOD. Students, see here. BCD. BCD. This is an arc to the circle. BCD is an arc to the circle. And if angle BCD is subtending some angle, if angle BCD is subtending some angle at center and it's y, then can't we say that if angle BOD is y, which is subtended by the arc BCD, this BCD arc is subtending an angle of y at the center, then when the same arc, it will subtend at the other part of the circle, the rest of the part of the circle, that is BAD, this angle is formed and this will be equal to half of angle y, right? So we can say that angle BOD, which is y, that's equal to half of angle BAD, right? Because here BCD is the arc which is subtending the angle A over here and angle X over here at A. Then the same arc will subtend twice of this angle at center. This is the theorem, right? So we can say that angle BOD is equal to y, which is equal to half of angle BAD. And what is the value of angle BAD? It's x, and we have calculated x as 45. So y will be equal to not half, sorry, it's mistake. It's 2 times BAD. So 2 times x equal to 2 into 45 equal to 90 degree, right? So 90 degree is the angle subtended by the arc BCD. 90 degree is the angle subtended by the arc BCD at the center of the circle, right? 90 degree is the arc subtended by the circle at the by the arc at the center of the circle, right? Now the angle y can be said as 90 degree. So this third part is also solved, it's 90. Now what is the next? The last part of the question is that angle BOD. So angle BOD exterior. So BOD exterior is this angle, right? And this angle, at O, a complete angle is formed. So we can say that Z plus Y equal to 360 degree. And what is Z? Z is same BOD exterior, right? So we can say that Z is equal to 360 degree minus value of Y. What is the value of Y? It's calculated as 90. So 360 minus 90, you are getting the value as 270 degree. So this is also calculated, the last part of our question, that is 270 degree. Right, students? So in this way, we can solve such questions. Okay. Yeah, I want to see if any doubts with you. Otherwise, I will take up another question. So another question which I have put into the shorts yesterday, I will just trying to cover all those questions over here. Okay. In that yesterday shorts, that was a question. There was a question that a circle is given. Okay. A circle is given. Let me draw it. Let me fix the pages. So here a circle is given and the question of probability is like that. A circle is given and ABCD is a rectangle. If this is the center of the circle, then here it's A, then B, then here C, then here D. This rectangle is formed. Right? And BOD is the diameter. Right? We need to find the probability of dart. The probability of dart, that means when you are trying to just throwing an arrow just for shooting. Okay. When you are throwing it from a distance, then probability of dart landing in shaded region. Shaded region. So if this is the shaded region, 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 probability of dart landing in the shaded region, we need to find. It's given that the length of AD as 8, the length of rectangle is 8 and this is 6, right? If this is 8, this is 6, that means we can say that length of AD equal to BC equal to 8 centimeter is given, and AB is equal to CD equal to 6, it's given, right? Now we need to find the probability of dart landing into the, when we are throwing it, it's just going and it will hit in the shaded region. What is the chance of that? What is the probability? What is the favorable outcome you are having, right? So here we can say here we can say that if this is 8, AD is 8, AB is 6, then this is a right angle triangle, isn't it? This is a right angle triangle, and in triangle BAD, in triangle BAD, right angle at A equal to 90 degree, means right angle at A, this is 90, right? Now we need to find the value of this probability that dart is landing into the shaded region when you are throwing it from a distant place. Okay? Now, probability can be given by what is the favorable outcome? Area of the shaded region. Area of shaded region. Shaded region will give you that area where the dart can land, and that is your expectation. So that is the favorable outcome, that will give the favorable outcome. That will be divided by the total area of the circle, right? Because circle is a place where the dart can land anywhere. When it will go into the shaded area, that is the favorable outcome. When will it will go and land into the rectangular portion, then it's not a favorable outcome, right? So students, what is the area of shaded region? Area of the shaded region is calculated. How? Area of the shaded region is calculated as, if this is R, if this is R radius, then area of the shaded region is pi R square, area of the circle, minus area of the rectangle, that is 8 into 6 divided by area of circle. You got it? I have written 8. This is circle. This is circle area. And this is rectangle area. Rectangle, this is circle. And this is also circle. Now, the pi r square value cannot be calculated over here because we are not knowing the value of r. That r need to be found. So in triangle BAD, what we have written over here, in triangle BAD, can we say that 6a square plus 8a square equal to BDA square. That is the diameter. So we are writing 6a square plus 8a square, and when we are taking root over of that, that will give you the length of BD, and when this will be divided by 2, this will give you the value of R, right? And 6a square plus 8a square is 36 plus 64. 36 plus 64. So it will give you 100, and taking root over of 100 will give you 10. So 10 by 2 is 5. I hope you are getting it. 10 by 2 is 5, and the value of radius is equal to, this is equal to 5, right? So if this radius is calculated as 5 here, if this radius is calculated as 5 by using the Pythagoras, we can say that the area of the given circle can be calculated. So do one thing, it's pi. So pi into r square will be pi into 5 square, right? Minus 8 into 6, it's 48, divided by pi into 5 square, right? So this will give you the value 25 pi minus 48 divided by 25 pi. This is your answer. So this is your answer. So just solve it to get the value of the probability of dart hitting the shaded region. So this will give you, now taking another question from a numerical of physics. Where we need to find the focal length. Find the focal length of a lens. Focal length of a lens whose power is given as minus 2.0 D. D is the diopter, Power of the lens is measured in diopter. Now, we need to also find the type of this lens, right? Here you can see So we can see the focal length of a lens. We need to find where power of the lens is given at minus 2.0 d. It's very common question, and we know the relation that power is related as 1 by focal length, right? And what is the value of power? It's given that minus 2.0 in diopter, right? So when this is in diopter, the lens, the power, the focal length will be coming into meter. So it is 1 by focal length. Or you can say if the focal length is coming into the LHS, we are getting 1 by minus 2. So this will give minus 0.5. So minus 0.5 meter is the focal length of the lens. And since negative, it implies lens is diverging. That means, what's that? That's concave lens. Lens is concave. Right? Hope students you like the today's session, and I will come up with future sessions also. Just keep on learning and happy learning. Bye bye.